Simply completing the square. To complete the square, you look at middle term, take the middle term, divide it by 2 to get 5, and then square that term to get 25, and this number is what completes the square, because what happens here, if you take the number that you took when you divided by 2 and put it here, that gives you a perfect square. This becomes x minus 5 times x minus 5. So to complete the square with something in a fraction, you just, again, divide by 2, or the same thing as multiplying by 1/2, square it. That's 1/36. 1/36 goes here, 1/6 goes here. There are several ways to solve quadratic equations. The first, you can simply factor. This one does easily factor, but if you have a coefficient in front, sometimes we use the method that we call bottoms up, where we take the first term, multiply it to the last, then we factor to see what multiplies to -6 but adds to -5. Well, that's -6 and but +1, so x minus 6 times x plus 1 equals 0. Here's the part that a lot of students forget. If you're going to use bottoms up, you can't just leave that 2 over there. We weren't really allowed to do that. So we have to divide each of these terms by 2. If this simplifies, we're just going to leave this as x minus 3, and we're going to bring this, if it's still in a fraction, to 2x plus 1 equals to 0. So our answer is x equals 3, x equals -1/2. There are many equations that we can put into quadratic. Here, if we just FOIL or distribute and move some things around, we get minus x minus 4 equals 0. You can tell that this doesn't factor, but we can always use our quadratic formula for that. A, B, and C is a coefficients in front of each of these terms as long as you write them in order. So here, our B is a -1, so -1 plus or minus square root of B squared minus 4 times A times C all over 2 times A, or 1 plus or minus square root of 17 over 2. And those are your two answers because it is plus or minus. One, kind of like solving rational equations again, going to multiply both sides by the common denominator, which is x plus 3, and x plus 3. When I distribute, x's cancel here, so this will be 5x plus 3. X plus 3's cancel on this one, so you just get a 5x, and I just have an x squared plus 3x. Multiplying through, I get 5x plus 15 plus 5x. Move everything over to get this side equal to 0. So I'm subtracting 10x from both sides, minus 15. Here I've labeled my coefficients A, B, and C. So A is 1, B is -7, so -7 plus or minus square root of -7 squared is 49, minus 4 times A times C, all over 2A. Simplifying to this answer. Back to those distance and rate problems. Looking at my problem, I know that he travels 120 miles at a certain speed meaning I don't know what it is, so it must be x, and he travels 120 miles at that speed. He then rides another 100 miles at a speed that was 10 miles per hour slower, so he rode another 100 miles at a speed that was 10 miles slower than his original. If the total time of the trip was 4 hours, so that means that this time plus this time must equal 4 total hours. So remembering that this t is the same thing as d over r. So this is 120 over x, that's this time A, and time B must total up to 4 hours, plus 100 over x minus 10 must equal 4. And I can solve this by multiplying both sides by my common denominator, which is x minus 10. And I multiply to get this. Let's move everything over. Factoring out of 4, simplifying, I can factor that one more time, and I know that it goes into 60 goes into 305 times, so I can multiply that, so I know that x is either equal to 60 or x is equal to 5. His rate couldn't possibly be 5 because he couldn't travel 10 miles slower than 5, so his rate must be 60 on the way out, and since it's minus 10, 50 on the second leg. Solving formulas, you just have to recognize when something is and when something is not quadratic. Here I'm going to multiply by 2 because I wanted to solve for h. So this is going to be 2g equals h squared plus 5h because those 2's are going to cancel. I see an h squared and an h, and since I can't get those things by themselves, I'm just going to treat this as a quadratic equation where coefficient a, coefficient b, and this whole thing here is coefficient c. So b, negative b plus or minus square root of b squared is 25 minus 4 times a times c is not just 2, it's negative 2g all over 2 times a, and that can simplify to 8g over 2. If I need to solve or write a quadratic equation where 5 and 6 are solutions, then I'm just working backwards. X is going to equal 5 and x is going to equal 6, which means that my original solutions were this. And working backwards, multiplying through, x squared minus 6x minus 5x is 11x plus 30 equals 0. And that's something that is quadratic. If I have something that is not just x squared and x, and I have something that kind of looks quadratic, I can reduce this to quadratic by letting x, or letting y, equal x squared, this middle term, because I know that y squared equals x to the 4th, right? If I squared y, then I square x, and that would be x to the 4th. So I can rewrite this. This will be y squared y. I'm just going to rewrite this equation, and now I have something that does look quadratic. So I can just do bottoms up, or I can factor or use quadratic equation. And factoring is actually the easiest way to go this time. If you just have this. So 9y minus 5, y minus 1 is going to be equal to 0. So y must be equal to 5 over 9, and y must also be equal to 1. I do have to bring this back. So since y equals x squared is the one that equals 5 over 9, and x squared is the one that equals 1. And then I need to take the square root of both sides. And remember, when I take a square root, I get both the positive and the negative answer. So x is plus or minus 1, and here x is plus or minus square root of 5, and square root of 9 is 3, so plus or minus the square root of 5 over 3. Same thing with this t to the 1/2 plus 2t to the 1/4 minus 3 equals 0. If I let y equal t to the 1/4, then y squared would be t to the 1/4 squared. And when I square something with a power, I multiply, so that's t to the 2/4, so that actually is t to the 1/2. So this is really y plus, or y squared plus 2y minus 3 equal to 0. Factoring this is pretty simple. Y plus 3, y minus 1 equals 0, so y must equal negative 3, y equals 1, and since y was equal to t to the 1/4, so t to the 1/4 is equal to negative 3 and positive 1. To solve for these, I just bring these to a 4th power. 1 to the 4th is just 1, and negative 3 to the 4th is 81. If you're looking to graph a quadratic equation, this actually gives you all the information you need. This A will tell you if it's negative, the graph is going to point down, or if it's positive, the graph is going to face upwards or open upwards. This H is going to be your x-coordinate, so this negative H is actually going to become positive. So like if it's x minus 2, then you're actually going to have a positive 2. This K, this whole thing is going to be your vertex. The K itself is also going to be either your minimum or your maximum, depending on which direction your graph is opening. And the H is going to be your axis of symmetry. So here, this negative tells you that your graph is going to be opening down. Your vertex is going to be negative 2, 1, because that's H, K. 1 is going to be, since it's pointing this way, this is going to be a maximum. So your maximum is 1. And your axis of symmetry is going to be negative 2. To actually get some points for this graph, I'm just going to plot in some random numbers. I'm going to start at the vertex. So if I plug in a negative 2 into this equation, then I'm going to get a 1. And then I'm just going to go left 1, right 1. So negative 1 and a negative 3 would be to the left one space and to the right one space. If I plug a negative 2 in, I'm sorry, a negative 1 in, I get negative 1 here squared is 0 is 1. Negative 1 plus 1, I actually get a 0. Negative 3, get the same thing, I get a 0. I'm going to go one more space, one to the left, one to the right. And these numbers should all come out to be the same. If I plug a 0 in, I get 0 plus 2 is 2, squared is 4, negative 4 plus 1 is negative 3, and I would get the same thing here. And your finished graph would look like this. If I'm looking to find a vertex of something that is not in that form shown previously, and you just have a typical quadratic, you can always just plug into these two formulas to find the vertex, or even simpler, you can just plug into this to find the x-coordinate and then solve by plugging this in to get your y-coordinate. So here you would get negative b is negative 2, a is negative 1, so it's 2 times negative 1. Not going to do the other side yet, but here negative 2 over negative 2 is just 1, so negative 1, comma, something. Instead of plugging it in, I'm just going to plug that negative 1 right into here, so that's negative 1 squared minus 2 times negative 1 plus 7, so that's negative 1 plus 2 plus 7, so that's 9 minus 1 is 8. So here, my answer should be 8. Knowing that my vertex is here, again, I'm going to go 1 to the left and 1 to the right. If I plug in 0, I should get 7. If I plug in negative 2, I should also get 7. Would be, and I'll just finish plugging in 4, here, and I should get. There's my graph, my axis of symmetry is negative 1, and my maximum, I can tell that it's a maximum, is 8. To solve inequalities that are in quadratics or any kind of polynomial, I'm always just going to factor and find what these x's are going to equal to, and those are going to be kind of my points where it changes from positive to negative or negative to positive. So if I factor this one, I get x plus 5, x minus 2 is less than 0. So that means that x has to equal negative 5 or x equals 2. Those are going to be my points on my number line. So if here's negative 5 and here's 2, I want to look for a point here, and a point here. I'm going to plug those points into my original and see if they are less than 0. So let's say I plug a negative 6 in. I plug a negative 6, I get 36 minus 18 minus 10, and that gives me positive 8. So I'm going to get a positive over here. If I plug in, let's say 0 in here, I get 0, 0, negative 10, so I get a negative number. And if I plug in a 3, I get a 9, plus a 9 is 18 minus 10, I get another positive. I really only want this area because that's the one that's less than 0, so my range is going to be where x such that x is greater than negative 5 but less than 2. Or you could say negative 5, comma 2. For something that is rational, you want to find, one, what this cannot equal, because if x equals 4, that makes this equation not real. So I'm going to say x cannot equal, negative 4. That's what would make this not real. And then I'm going to solve again. So if I solve x minus 2 over x plus 4, just changes to an equal sign. It doesn't really make a big deal right now. Multiplying both sides by x plus 4 gets me x minus 2 equals 0, so x must equal 2. So my 2 points are here at negative 4 and 2. Plug in a point like negative 5. If I plug in negative 5, I get a negative 7. Negative 1 gives me a positive. If I plug in a 0, I get a negative 2 plus 4 gives me negative 1/2, which is a negative. If I plug in a 3, I get 1 over 7, which is a positive. So I'm looking for these two areas because they are greater than 0. So to write out, I would have negative infinity to negative 4 union to infinity. I could also have this answer. For this last problem, I'm going to factor again. This becomes x squared minus 7x plus 12 is greater than or equal to 0. Factor one more time, x minus 4, x minus 3 is greater than 0. And now I have 3 terms. Here's my number line. I really just have to look at the signs for this. If I plug in a negative 1, I'll get a negative, a negative, a negative. 3 negatives make a negative. If I plug in a 1, I'll get a positive, negative, negative, which makes a positive. If I plug in a 3.5, I get a positive, a negative, and a positive, making the overall term positive times positive is a negative number, and anything greater than 4 would be positive, 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 which would be positive. I just want this and this, so that'll be between 0 and 3, and 4 and infinity.